my name is Thuruvan, and today I'll be walking you through what I did for Lab 4, which covers Chapter 7 and 8 of the Art of Network Penetration Testing. These two chapters are all about what happens after you have done your reconnaissance, specifically how you actually break into system and what you do once you're inside. So just to give some context for anyone who wasn't here for the previous presentations, in the earlier labs, we covered the information gathering phase. That meant scanning for hosts, identifying services, finding vulnerabilities, and then attacking things like web servers, database, using default credentials or misconfigurations. But the question we are answering today is what do you do when none of that works? What if there's no login page, no default password, nothing obvious to exploit? So that's where the unpatched services come in. So let's talk about what an unpatched service actually means. Every piece of software has bugs. That's just the reality of how software gets built. Most of the time, bugs are just annoying, but occasionally a bug is serious enough that an attacker can use it to take over the machine running that software. When a vendor like Microsoft discovers one of these bugs, they release a patch, basically a fix. The problem is not every company installs that patch right away. Some systems get missed, some are forgotten, some just never get updated, and when that happens, you essentially have a door that's unlocked. The best kind of vulnerability from an attacker perspective is one where you don't need anyone to click anything or do anything. The service is just sitting there, listening and waiting to be exploited. So the specific vulnerability we are working with here is called MS17010 EternalBlue. It was patched by Microsoft in 2017. It was actually the 10th patch they released that year, which is where the name comes from. Uh, what makes the EternalBlue particularly powerful is that it targets the SMB service. That's the file sharing protocol that runs on port 445, which is active by default on pretty much every Windows machine in a corporate network. Sorry. And the really scary part is that you don't need the target to do anything. You just point the exploit at the IP address and then just run it. That's what makes it one of the most significant Windows vulnerabilities ever discovered. So here's what I actually did, where I will do a live demonstration for you after the presentation. So first, I'll be using Metasploit scanner to confirm that the target was missing the patch, and it came back saying the host 227 was likely vulnerable, running Windows Server 2008. Then I loaded the EternalBlue exploit module. I should mention the book actually tell you to use a slightly different module called Post-Exec, but that didn't work in my environment, so I used the EternalBlue module instead, which worked perfectly fine. I set my payload to a meterpreter reverse shell, pointed at the target, and ran the exploit. Within the seconds, I had a system level shell on the machine. System is the highest privilege level on a Windows machine, essentially full control. Now, the shell I got wasn't just a basic command prompt. It's something called a meterpreter shell, and it's significantly more powerful. The big difference is that meterpreter runs entirely in memory. It doesn't write anything to disk by default, which makes it much harder for antivirus to detect. It also communicates over an encrypted channel, but practically speaking, what makes it useful is all the built-in features. You can upload and download files directly. You can manipulate process on the target, and the most important, you have access to a whole library of post-exploitation modules that automate a lot of work that you would otherwise have to do manually. One of those modules is Smart Hashdump, which I use to pull all the local account password hashes off the machine automatically. The book also covers something called custom shellcode generation, which is worth mentioning. There's a public website called exploit-db.com where you can find thousands of exploits for known vulnerabilities. The problem is that shellcode embedded in those exploits, which is the part that actually gives you your shell, might be outdated, broken, or in some cases even malicious. So the recommended approach is to generate your own shellcode using a tool called MSF Venom, and then swap it into the exploit before you use it. I demonstrated this by generating a reverse HTTPS meter payload showing where it would replace the existing shellcode in one of the exploit DB examples. So now we move into chapter 8, which is all about what you do after you have compromised a machine. And the book breaks this down really nicely into three objectives. The first is making sure you can get back in because your shell could die at any moment if the service crashes or the machine reboots. The second is harvesting credentials, passwords, hashes, anything you can find because those credentials are your ticket to other machines on the network. And the third is lateral movement, using what you found on the first machine to get into the other machines that you couldn't reach before. These three things together are the core of post-exploitation. So first objective, maintaining access. I installed a persistent backdoor. The book shows a specific command for this, but it didn't work in my environment, so I used a Metasploit module called exploit Windows local persistent instead, which does the same thing. What it does is write a small VB script file to the target machine and register it as a Windows auto run key. So every time the machine boots, that script runs and calls back to my attacking machine. I also had to migrate my interpretation into a process called services before rebooting because that gave me the necessary permission to actually trigger the reboot. And after the machine came back up, and if a user logged in, I got a fresh interpretation automatically, which is exactly what we want. For credential harvesting, I used three different techniques. The first was something called Mimikatz or Kiwi, as it's now called in Metasploit, which can extract clear text password directly from Windows memory. This works because of a design flaw in how Windows handles authentication. It's need to store the password in memory in a readable form for certain functions. I ran the tsp kg command and got the plain text password for the TN ADM account just sitting there in memory. The second technique was extracting domain cached credentials. These are hashed versions of passwords that Windows stores locally so users can log in when they are not connected to the corporate network. And the third was using the smart Hashdump module to pull the local NTLM hashes for all accounts on the machine. So in this way, we can all get the hashes of the administrator and all the other accounts in the machine, and then we can use those account and hashes to log into the other machine. For example, if we log into through a domain account, this domain account can be logged into the other machines in the same network. So now the domain hash credentials are we extracted. They are hashed using a format called MS cache version 2. And unlike NTLM caches, you can just use them directly to log into the other machines. You actually have to crack them first to get the plain text password. So I compiled the John the Ripper from source and use it to crack the hash. I first tried it without a word list, which is basically just brute forcing every possible combination of characters as you would expect. That's painfully low. But then I used a word list called rocku.txt, which contains about 14 million real passwords from data breaches, and it cracked the password 3210 in under a second. But eventually it could take a lot of time, depends on where the password is on the rocku.txt file. So in this way, we can honestly say a lot of about why policies matter. You have to have a hardened password, including uppercase, lowercase, simple, number, more than eight characters, so that it's hard for them to crack with a password hash. And finally, lateral movement. The technique here is called pass the hash. and it's one of my favorite things about Windows security, or I suppose the lack thereof. The idea is that Windows lets you authenticate to a machine using just the NTLM hash of a password without ever needing to know the actual password. So if an administrator reuses the same local admin password across multiple machines, which happens all the time in enterprise environments, you can take the hash from one machine and use it to log into all the others. I tested this using both Metasploit SMB login module and a tool called NetExec, which has replaced CrackMap exec in current Kali versions. In my lab, the credentials were unique to TN, so I didn't unlock any machines, but the technique itself worked and the hash was confirmed valid. In the book scenario, this is how you would go from one compromised machine to potentially owning the entire network. And that's really the key takeaway. One vulnerable machine, if you do post-exploitation properly, can be the foothold you need to take over everything. And thank you. We'll move on to the live demo of the chapters. Live demo. So first of all, we'll check whether the target machine is alive. So we just did a ping command and we can see it's alive. And the next step, we have to see whether the MS170 exploit is there on the target machine, whether that machine is vulnerable to that EternalBlue attack. So we should use the MSF console. Let's get inside the console and then first we will check whether this machine is exploitable to that vulnerability. We'll just choose it. Set our host 10.0.10.208. Yes, and then run. As you see here, it says host is likely vulnerable to the EternalBlue attack, and it says Windows 7 Professional Service Pack 1, 64-bit. Okay, so we can get into to the exploit as we have explained before in the presentation. The PSC exec payload, the exploit didn't work, but the EternalBlue attack worked. So we'll just get to the attack. We'll get this command to get the attack and then payload. This is the payload for the reverse shell meter. Then our host 10.0.10.208. Then lhost is this machine. Or we can just use ipconfig here. Sorry, we have already got that IP here. Start 60. So set lhost 10.0.10.16. Sorry, 60. And these are the only options we need to do. So first use the exploit module and then set the payload and then set the rhost and then set the lhost. Lhost is the one receiving the reverse shell and then to exploit. We may have to wait a bit to get the yes, we got the machine. We'll just do simple commands. The shell CMD commands and the meter commands is different. So here we just did ipconfig. We were able to see all the network interfaces that machine has. So we can see 10.0.10 similar to we can get inside the CMD by just typing shell and then press enter. We got the CMD. We can check who am I here. We can see the system level authorization. So after we got the machine, got into the reverse shell, we had to establish a backdoor. Let's say the system crashed because of the meter because it's gonna overflow the memory or something bad happened to the system or manually restart someone restarts the system, we're gonna lose the shell, right? We don't need to do it manually again and again. So what we have to do is enable the backdoor. So the command which was on the book wasn't working. Maybe it's outdated. So we have to use MSF console uh, module to make the backdoor work. So what we have to do is go back to the sorry exit from the CMD, go to the quicker, and then do background. And then we can do some commands here and then go back. So what we have to do is use a module now to install the reverse shell as a startup service or start when the Windows machine reboots. It's gonna so we'll just get back here and then use this module in the Metasploit MSF console. Enter. Yes, and then we'll set the session. So this is session ID. So as you can see, this is the session. You can get the session ID like this. You just do sessions. We can see one session to this IP using interpreter. So we have to set the session ID as the one we have. And then we'll just set it up as startup system. Is the virtual machine it has to contain the port. It has to send the reverse interpreter connection, and we'll do the exploit. So as you can see here, it's running the persistent module on that target machine via the session ID. So first it created the VBS script on the Windows temporary folder, and then add that script to the Windows registry. So as you see here, when the system reboots, it's gonna run that specific registry, and then it's gonna run the temporary VB script. So to do the exploit, we have to actually reboot the machine and then listen on the specific port we mentioned here. We have to start the listener, okay? So first of all, what we can do is we go back to the sessions. So you see here, we can't simply reboot. When we do reboot, it's gonna say operation failed for some reasons, but we can do PS. So when you do PS, you can see the process list here. So you can see all the process. What we have to do is check the services.exe and check the process ID here. It says 496. So what you have to do is migrate this meter session to that specific uh, service because we are on the memory. The meter session is on the memory, so we can just switch into different services that are running different processes which are running on the memory. So 496. Give me a second. Do PS again. And so .exe is 496. Give me a second. Yep, there's no dash, just this. So it says currently migrate from 1184 to so this the specific printer spool service. So we could see here when you check on the system that it was it's migrated from here to here, and then it says migration complete, and we just reboot here. When you go to this machine is rebooting. So while it's rebooting, we go back to the select console and then start the listener. Set this payload. And we'll do the export. But you can see this old session is that, but no new. Oh, sorry. We had just for because that's the code we have used before. When you go back, you can see it's just 4 times 4. Back, as you can see, started the listening. But the tricky part is someone has to log in into that machine, then only it can get this session, meetup session. So we'll simulate the login. So you can see here we can be logged in here. So we just wait a few minutes, few seconds, and you can see this session is open here. So we just get inside the session. So we are already inside the session. So yep, we got the session. So now we have done the backdoor. So when the machine reboots, whatever happens, we're gonna get the shell somehow. Machine, we have to harvest credentials on the local machine and the domain accounts. So for that, we can use Mimicat. So we just need to do load Mimicat. But there's a Mimicat extension has been replaced by Kiwi, so we have to use commands from Kiwi. So this is a command we can use to get the credentials in plain format. So you know Windows keep the credentials on the memory, not on hard disk, but on the memory after the user logged in their login page. It keeps the password in the memory to do some task which no one knows. So but we can get that password from the memory, like a plain text password. So what we do here is copy into this command. Sorry, there was a dot. Yep. So you see here, this is the username of the machine, and you can see the password is password. This is the password of the username. So we have successfully gathered like the password of this user on the local machine. We don't know whether it's a domain account or a local account. It shows TN as a domain, but it's the machine actually connected to the capsule Gulf domain as you see here. So the next command we can do is hit get the credentials in hash format. So we'll just do here, and then you can see the domain details here. So we can confirm this is a domain. We can see a domain. This is a domain username related. Somehow it got logged into that machine before, or because this is a different machine as you see here. So this username has been logged into this machine somehow. So we can get this hash and then use John the Ripper to get the password. So we can only it's like brute forcing the hash. So hash is not reversible. So what it will do is check make the hash of the each password using the same algorithm, and then compare with this hash, and then when if the hash matches, then it shows that's the password. So we have to get this password. What we can do is we can use the common words list, which is rocky.txt. We can use that in the raw your the Reaper tool to brute force the hash. So we'll do that. So first we have to save the hash in a text file so that we can use in the John the Ripper tool. So we shouldn't just we shouldn't just copy this hash and then save it in a text file. there's a format for that John the Ripper can use it. So as you see here, it's the username and the type of DCC2 or DCC, and this is how many bits, and again the username and then the hash. So in and then double colon. So this is a format we have to choose. Then press enter. We save the file. First of all, we'll run the John the Ripper without any dictionary, without specifying any text file which has the password. So it will run. It says no password. So that it was I have already brute forced the password, so the John has saved that for this hash, this is the password, so you can see here. But I'll remove the pod file, so you will just the pod file is right here. We'll just remove it, and we'll do oh, so it's you can see zero password hash is cracked, one left. So this the we'll do this command. So this without a dictionary. So you can see it uses its default password list to figure out the password, but we may not know whether it has the password or not. We just do with our word list, which is logq.txt. So we just run it, and then we can see it got the password. So this is the real password of that machine. So this the golden ticket, like we got lateral movement, lateral different user other than that machine. Like it's a we can use this credential to log into the other machines in the domain. For the sum of the machine, it could be the admin account. We don't know. We can try log in and then check. So this one kind of thing, and then next we will do, and then next we will use these hashes to log into the other services, other machines to check whether this log credentials works to lateral movement to move on to the other machine from this machine. Before that, we'll get some hash from here, hash down. So this is some hash from the local machine, this from the admin account, guest account, and the other account. We just copy it, paste it here. We can use this hash to try the, like a shell. But we can go to the GUI and search for something. But there are some files which has the username password in plain text. So we can get inside the file and then check the credentials. For example, if a Tomcat service is running, we can check like that. As you see here, this is the default file name, which has the configurations and username and passwords there. So for Jenkins, it's gonna be in this names. For Microsoft IIS, it's gonna be in web.config. For Tomcat, tomcat-users.xml. So for PHP, my admin, this is the file. So we can just search for, like, let's say all the files in the C directory which has the text password. So we'll just go here, go back to the session and find the shell. And this is the command, and I have copied it. So you can see here find string inside C directory which has the password. We can't even remove the equal sign, and then you just press enter. But it will eventually take a lot of time to search for all the files and check for the keyword password. So this is one of the way, but you'll be lucky if you get some good results here, so you can use it to get inside those services. So next what we will do is use the hashed We use the hashes we got to log in, to try log into the other services inside the machine to get some more access so we can try log into the SMB and then whether we can see uh, we can get the files from the SMB. So we'll just do that. We set the SMB user to the admin, set the SMB pass to this one, the center, set the SMB domain here, just start, set R5, host, discovery host, windows.txt, enter. We set the thread. So thread means like at the same time, it's gonna run on 10 different machines, 10 different tasks at the same time. So it's gonna do 10 to and this one. It's you can see it's starting SMP login brute force. So yes, you see here it says correct credentials but unable to log in. Maybe the SMB login to the administrator account is disabled on this machine, but the credentials are correct. So it eventually failed, but we were able to confirm the hash is correct for this admin account. So the next thing we can do is using NetExploit uh, to use the hash to log into the services. For example, we can do the same SMB login which we did from the hash. So we'll just use this one, this username and the hash to log in to different services in this entire network. So the command X. So you can see here it says SMB and the network is the whole network, so it's gonna run on the whole network, and then it uses the username here and the hash as we got from the meet reversal session. So we just enter here. It's gonna run on everything. So as you see here, plus sign here, which means it was able to successfully log in, but sadly we were only able to successfully log in onto the same machine, not other machine, because my other machines are not running. We can do this. We can try test it out by running the different machines. Only there's the server is running, so it's gonna eventually fail on that. But we can confirm that it works. It's gonna be able to log into the other machines too. So this method is called pass the hash. So we got the hash from one machine and then using that hash to log into the other machines in different services. As example, we use the SMB service here. We can try log into some other services. Similarly, how we use the TN ADM account, we can try test out with the administrator account here. So we'll get you specify the username as admin and the hash as the admin hash here. Just press enter. Let's see whether it's able to log in with some other services. As you see here in the TN account, it says TNS account disabled, which confirms the password is correct, but the admin login is disabled here. And all the other machines, it just shows login failure. So sadly, these accounts are only for that specific domain. Sorry, that specific machine, not the other machines. So that's the end of the chapter 8. We will move on to the next chapter in the upcoming videos. Thank you for watching. This is me Thuruvan.